Hello and welcome to yet another video of Cornerstones of Math. Today we will solve this multiple choice problem where you have to choose one or more choices that are true. Let's read the problem. Set S is a subset of the set of real numbers and satisfies following properties. First, 0 is an element of S. Second, for an arbitrary non-zero real number A, one of A and minus A is an element of S, but not both. And third, if A belongs to S and B belongs to S, then AB also belongs to S. Given that these three conditions are always satisfied, choose the correct statements among the following. First, if A is the set defined as an intersection between S and the set of X satisfying the cubic equation x cubed minus 9x equals 0, then A has two elements. B, if negative 2 belongs to S, then 32 belongs to S. C, if R belongs to S and R is a non-zero element, then 1 over R belongs to S. Alright, let's solve this problem. Obviously, we are going to investigate these statements one by one and check whether they are true or false. So the first choice A, first we have to investigate what would be the elements of this set. It is the set having elements x that satisfy the equation x cubed minus 9x equals 0. So let's solve this equation. We can easily factorize the left-hand side to obtain x squared minus 9 equals 0. So x plus 3, x minus 3 equals 0. So we have x equals 0, 3, and negative 3. Therefore, A is the intersection between set S and set having negative 3, 0, and 3 as its elements. Here, from condition 1, which states that 0 is always an element of S, we know that 0 is an element of A because it is both in set S and this set. Next, we take a look at condition 2. It says that for an arbitrary non-zero real number A, only one of A and minus A belongs to S. Therefore, between 3 and negative 3, only one of 3 and negative 3 is an element of S. Therefore, A is a set having elements 0 and 3, or 0 and negative 3, and in either case, A has two elements. Therefore, we know that the choice A is true. Next, choice B. Here we take a look at the third condition. If A belongs to S and B belongs to S, then AB belongs to S. We are only given that negative 2 belongs to S, so we apply condition 3 by multiplying negative 2 with itself. This gives that 4 is an element of S, and if we multiply 4 with 4, then we have 16 is also an element of S, and then let us pick negative 2 and 16 this time, which gives negative 32 is also an element of S. Here, because negative 32 is an element of S, condition 2 excludes 32 from being an element of S. Therefore, choice B is false. Finally, choice C. Here, since R is non-zero, we know that 1 over R is also non-zero. Also, by condition 2, either 1 over R belongs to S or minus 1 over R belongs to S. Here, let us assume that minus 1 over R belongs to S. Then we apply condition 3 with two elements minus 1 over R and R, which are both elements of S. This gives negative 1 belongs to S, but this also gives negative 1 times negative 1, which is 1, also belongs to S, which contradicts the condition 2. Therefore, this assumption must be false, meaning that minus 1 over r does not belong to S. But I have already mentioned that by condition 2, 1 of 1 over r or minus 1 over r must belong to S. And since minus 1 over r does not belong to S, the only remaining option is that 1 over r belongs to S. Therefore, choice C is true. Therefore, true statements are A and C. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.